Hello everyone. Am I audible?
Yes, ma'am.
Yeah, so this is your week 7 doubt session. So you can start asking your doubt. So let's start with activity 7.1. Is my screen visible?
Yes, ma'am.
Okay. Okay, so anyone having any doubt in activity 7.1? Have you all tried solving the questions or not? Okay, in any other activity? 7.2, 7.3 or anyone? No one has any doubt?
Ma'am, 7.3. Question number 2.
Okay. So question number 2 is which of the following is are mutually exclusive events? Okay, so mutually exclusive means there should be nothing in common, right? Mutually exclusive. Also, we can say disjoint events.
Yes, ma'am.
Okay. So now the options are selecting a king and selecting a heart from a deck of 52 playing cards. Okay.
Yes,
So
ma'am.
just think about it. So you are selecting a card which belongs to heart. Okay.
Yes, ma'am.
So the card can be of a king also, right? Okay. So there are 13 cards in heart, right? Which belongs to heart. Okay. There can be a card of king, right?
Yes, ma'am.
So, so one card is mutual, like one card is common. Okay.
Okay,
So
ma'am.
these
Or
two,
ma'am, option number third. Sorry. Yes, ma'am. Option number third.
yeah. So
Ending
now,
left.
yeah, okay. Option two is clear. So king and ace are two different cards, right? So they both cannot be like selected at the same time.
Yes, ma'am.
Is that clear? Option number two.
Yes.
Okay. Now the thing is turning left or turning right while walking. Okay. So these two are different directions, right? So if you are turning to the left side, then at the same time you cannot turn to the right side,
Yes,
right?
ma'am.
Is that correct? Okay. So they both actually cannot happen at the same time.
Ma'am, option
Okay. So
number
that's
2
how
wrong, yeah, correct? Option 2.
option number two will be correct. Okay.
Okay.
Okay. You can check the answer.
Ma'am, but answer option number 2 wrong. Uh, Sorry. Option number first wrong. Sorry,
Option
sorry.
number, yeah, option number one is incorrect because they are not mutually exclusive. Okay,
Yes,
because
ma'am.
there is one card which is common. Okay, so option number one will be incorrect. Option number two will be correct because selecting a king and selecting an ace. Okay, they both are different cards. So if you are selecting one card,
Yes,
so
ma'am.
either it will be a king or it will be an ace. It cannot be both at the same time. Okay,
Okay, ma'am. Okay.
okay, so that's how option number two and three will be correct because they are mutually exclusive.
Yes,
Okay, and
ma'am.
option number four is also not mutually exclusive because you can perform these two things at the same time. Okay, turning right and scratching your head. So these two things you can do at the same time. So they both will not be mutually exclusive. Okay, so option number B and C will be correct. Okay, now is this clear?
Yes, ma'am.
Okay, any other question?
Ma'am, can you please explain question one as well?
Sorry, which question?
Ma'am, question one.
Okay. So the king, queen, and jack of clubs are removed from a deck of 52 playing cards, and then the deck is shuffled. So let E be the event of getting a queen and F be the event of getting a club. So then the cardinality of the event E union F. Okay. So cardinality of event E union F, which means you have to tell the number of elements in the event E union F. Okay. So now let's see what elements will be there in E and F. Okay. So first of all, it is written that the king, queen, and jack of clubs are removed. Okay. So tell me how many cards are there for club in total? How many cards are there which belongs to club suite?
Ma'am?
13 cards are there,
Yeah, ma'am.
Yes, ma'am.
right? 13 cards are there which are of club. Okay. Now out of those 13 cards, we have removed king, queen, and jack. Okay. So
Okay.
these three cards are removed.
Okay.
Okay. Okay, and now the deck is shuffled, and then we are saying that event E is the event of getting a queen. Okay, so how many queens are there in total in a deck of 52 cards in general, in a standard deck of cards? No one knows it?
Three queens are there now. Three.
Okay, yeah. I'm asking in general in a standard, not in this deck of card. I'm asking in general in a
Yeah.
standard deck of card,
In
how many
general,
queens?
there are four queens in the deck of cards.
There are four queens. Okay,
Four
in
queens.
general.
Yeah, ma'am.
Okay. Okay, in general, we have four queens in a deck of 52 cards. But here we have removed the queen of club, right? So one queen is removed. So now we are left with only three queens, right? Is this thing clear? Okay. So in this event E, three elements will be there,
Yes.
right? Okay. One queen of club is removed. So we are left with three queens. Okay. So this is the cardinality for event E only. Okay. So three elements are there for E. Now F is the event of getting a club. Okay. So in general, in a club, we have 13 cards, but here we have removed three cards. Okay. So now we are left with 10 cards of clubs. Is that correct? Is that
Yes,
clear to
ma'am.
Yes.
everyone? Okay.
Yeah, ma'am.
Now we have to tell the cardinality of E union F. Okay. Which means we have to like add the cardinality of event E and event F. Okay. So three elements are there for E and 10 elements are there for event F. So total 10 plus 3, which is 13.
30.
Okay.
Yes, ma'am.
Now is this clear? Okay. Yeah. Next question. 'What is the next doubt? 7.4. Ask two doubts. Please keep asking your doubts. Don't be quiet.
Question number 4.
Question number 4. Okay. Shabnam has 74% chance of receiving an A in either statistics or mathematics. So find the probability that she does not receive an A either in statistics or mathematics. Okay. So just read the statement carefully and you can see that this is this line that she does not receive an A either in statistics or mathematics. It is actually the complementary event of receiving an A in either statistics or mathematics. Okay. So the probability of this event, receiving an A either in statistics or mathematics, this probability is given to us. Okay. And we are asked to find the probability of the complementary event. Okay. That she does not receive an A either in statistics or mathematics. So it will simply be 1 minus 0.74. Okay, 74%, which means the probability is 0.74. Okay, so the probability of complementary event will be 1 minus 0.74.
Ma'am,
Is that clear?
0.26.
Yeah, it will be 0.26.
Yes, ma'am. मैम अगर क्वेश्चन में आइदर रहेगा तो 1 माइनस कर देंगे, राइट? 1 माइनस.
Not like if there is either, then you will do 1 minus. Here in this particular question, you can see that this is the complementary event. Okay,
Yes,
so
ma'am.
if you have an event A, okay, so probability of A, okay, plus probability of the complementary event, okay, they both sum up to 1. Okay, so if you have to find probability of A complement, okay, so that will be 1 minus probability of A. Okay,
Yes, ma'am.
that's how we have calculated it.
Okay.
Any other question in this activity? Seven 7.5 or any other question from any other activity?
And in question number 2, as the percentage is given, we should take one like 100 and then calculate it accordingly.
Sorry, question number 2 for 7.5.
Yes, ma'am. Question number 2, like their percentage is given, we cannot directly calculate the probability. So can we take 100 and then do 57 and then 30 and 25 and then solve it?
Yeah, actually. So these 57% actually you can convert it into probability. Okay, so that will be 0.57. Okay,
Okay, ma'am.
and the probability of sample space is 1. Okay, that is from up to 100%. So that you can
Okay.
take as 1.
Okay, ma'am. Thank you.
Yeah, any other question? From any other activity? 7.6. Have you all tried the questions of practice assignment?
Yes, ma'am.
So practice assignment solutions are given. So you all tried the questions.
Yes, ma'am. Most of them are done.
Okay, anyone having any doubt?
Ma'am, if you don't
Question
mind,
number
can
10.
if that question where that wall part, like the area part, the previous one.
Okay, I'll explain with the given solutions. Question number
This
10.
one. This
I
question.
I have
Number
doubt
11.
in question number 10, ma'am.
Okay, I'll take question number 10 first, and then you can ask other questions. Okay, so question number 10 is, in a particular game, the player needs to throw a dart onto a circular board whose radius is 8.5 units. The points allotted to the player are based on where the dart lands. So let R be the distance at which dart lands from the center of the board. Then the points allotted are as follows. Okay, so it is like if the dart lands on this in the radius between 0 to 1, okay, then the player will get 10 points. Okay, similarly, if the dart lands on 1, 2, 3 between this radius, okay, then he will get 8 points. Okay, similarly, it is given for the other points as well. Okay, now the question is, assuming the player is not a professional and that there is an equal chance that that the dart could land anywhere on the board, what is the probability that the points is scored by the player in one throw is a multiple of 4? Okay, so multiple of 4. Okay, so tell me what will be the multiple of 4 in this particular question?
Ma'am, 0,
8
4,
points,
and
4 points, and
4
0
and
points.
8.
Yeah, it will be 0, 4, and 8. Okay, so we have to consider all these points. Okay, so we have to take the area of where the player will get 0 point, and where the player will get 4 points, and where he will get 8 points. Okay, so 3 things are there. So we actually need to calculate these 3 areas. Okay, and the total area, what will be the total area here? The total area, actually the board is circular board. Okay, so we have to find the area of the circle. Yeah, circle. Okay, so it will be pi r square. So you can see here, this will be the total area. Okay, pi into whatever the r is given here, it is 8.5. Okay, so pi r square, this will be the total area. Okay, so now we have to see what will be the favorable reason for us. Okay, so that we have to calculate. So first we have to calculate this area. Okay, between 3 to 1 to 3. Okay, so if I draw the figure of it, suppose this is the circle. Okay, circular board. Okay, this is the center. Suppose this is 1 centimeter. Okay, this is 1. This distance is 1. Okay, and then we have this distance. Suppose this is 3. Okay, so we have to take between 3 to 1 to 3. So the required region in that case will be this yellow region, right? Between 1 to 3. Okay, so we have to calculate the area of this yellow region. So how can we calculate it? Anyone?
Ma'am, total
Three
minus
minus up to the 3 minus that smaller circle. We have to take up to 3 the total circle of the radius, and we have to minus the
Yes.
radius with 1.
Yeah, correct. So what we can do? So we will take the circle pi r square, where r is equals to 3, right? And then we will subtract the area of this green circle, right? So you can see here we have to do pi 3 square minus pi 1 square. Okay, so that will give you the area of yellow region. Okay, similarly we have to calculate it for the point 4. Okay, where the player is getting 4 points. So that will be pi 7 square minus pi 5 square, right? You can see pi 7 square minus pi 5 square. Okay, you will get this area. So there is a mistake in the solution of this question. It has not included this reason. Okay, so we also have to include the reason of area of this region where r is greater than or equal to 8. Okay, so how will you calculate here? If you have to calculate this region, what will you calculate?
Ma'am, pi into 0.5 whole square.
So you can see that maximum the radius is 8.5. Okay, so it will be pi 8.5 square minus pi 8 square. Okay, so if you can see,
Yes, ma'am.
okay, if suppose this is the center, okay, and up to this point, okay, this is 8.5, okay, and suppose up to this is radius 8, okay, so we want this region, okay, greater than 8, which means maximum it can go up to 8.5, okay, so it will be pi 8.5 square minus pi 8 square.
8 square.
Okay, yeah, so this reason also you have to include. Okay, and then we will add all the 3 reasons, okay, and divide by the total area. Okay, total area we have calculated here, pi into 8.5 whole square. Okay, in this way you can get the probability of this, that the dart lands on the, okay, that the pair will get the multiple of 4 points. Okay, so the area for the last 0 point is not included here, so you have to include that also. Okay, and then you have to add all the 3. Okay,
Yes, ma'am, understood.
okay, what is the next question?
Hello, ma'am.
Yes,
Ma'am, last question, ma'am. Actually, my internet is not working properly, but I have to ask this question last.
last question. Okay,
Yes, ma'am. Ma'am, just explain. Yes, ma'am. This one.
okay, okay, so probability of C is given, probability of A union B is given, probability of A union B union C is also given. Okay, and we have to find the value of probability of A union B whole complement intersection C. Okay, so we have to find this probability. So we should know how we can calculate this thing actually. Okay, so there is the formula. Okay, here you can see this equation. So if, okay, if suppose, first of all, just see this thing. If you have probability, if you have to find probability of E complement intersection of F, okay, suppose you have 2 events E and F, okay, E and F are 2 events, okay, and you have to find this probability of E complement intersection of F, okay. So how can you calculate this thing? It is calculated as probability of F minus probability of E intersection F. Okay, is that clear?
Yes, ma'am.
If you want to visualize it, suppose you have 2 events E and F, okay, so E complement intersection F, so actually it is this thing, this is E and this is F, okay, so E complement is like apart from this circle everything is E complement, okay, and we have to take common with F, okay, so this reason, okay, this line, this is the reason for E complement intersection F, okay. Now look at this figure carefully, you can see from the F, okay, from the circle of F we have removed the intersection part of both the events E and F, okay. Now does this formula make sense? Okay, so this probability is actually equal to that probability of F minus probability of the common thing. A intersection F. Is this thing clear to everyone?
Yes,
ma'am.
ma'am.
Okay, so we have to use the same concept in this question. Okay, now you can consider that this A union B, let's suppose for an instance, you can consider it as some other event, suppose D. Okay, so now if you have to write this formula, probability of A union B whole complement intersection of C. Okay, so by using the same concept, we have written this thing. Okay, so it is like from C, you have to subtract the intersection of C and A union B. Okay, now this equation number 10 is clear to everyone? Yes or no?
Yes, ma'am.
Okay, so by using the same concept, we have written equation number 10. Okay, now we will find the other things. So probability of A union B is given to us, okay, which is 0.6. Probability of C is also given, which is 0.3. And probability of A union B union C is also given. Okay, these three things are given to us. Okay, now if you have to write probability of A union B union C, okay, so this is the formula, right? If you have to write probability of A union B union C, okay, let's take it writing one bracket here. Okay, so we can write it like this: probability of A union B. Okay, just consider it as like one event. Then we have to add the probability of C. Okay, and then we have to add the we have to subtract the intersection of these two. Okay, which means A union B intersection of C. Is this clear to everyone? Okay, by using the addition rule, you can write this formula. Is this line clear to everyone?
Yes, ma'am.
Okay. Okay, now let's go back here. Okay, now you can see A union B is given. Okay, probability C is given. Also, A union B union C is given. Okay, this is the same thing. If you, okay, you can write the same thing as this: probability of A union B, okay, intersection of C. Okay, just transfer these things to the left side. Okay, so that is equal to probability of A union B plus probability of C. Okay, and this will be minus probability A union B union C. Okay, these two are same. Okay, just transfer some elements. Okay, you have to calculate the value of this part. Okay, and now you just put the values. All the values are given in the question, and then you can find. Okay, so you will get
Yes, okay,
the
ma'am.
value of the intersection part, and then you can put the values in this equation number 10. Okay, is this question clear, everyone? Okay, any other question? Any other question from practice assignment 7.1? Anyone else having any doubt? No one has any doubt now? No one has any doubt now? Please keep
No,
asking.
ma'am.
Anyone else? Any other question from 7.2?
Yes, ma'am.
Okay. Which question?
Ma'am, 4 and 5.
4 and 5. Okay. Okay, so the main question is 90 students have participated in the annual cultural festival of a college comprising of singing, dancing, and acting competitions. The number of students who did not participate in the acting or dancing competitions are 10. The number of students who participated only in the dance competitions are 15. The total number of students who participated in the acting competition are 50. The number of students who participated in both the singing and acting competition are 20. And the number of students who participated in both the dancing and acting are 15. So the students who participated in all the three quizzes, all the three competitions are 10. So this information is given to us. Then we have to find in question number 4, what is the probability that a student selected at random participated in both singing and dancing competitions. Okay, so we can make a Venn diagram for this question, and then we can find out how many students are there, okay, which are participating in both the singing and dancing competition. Okay, so by using the Venn diagram, we will find the required number of students, and then we can divide by the total number of students, and then we will get the required probability. Okay, so let's make a Venn diagram. So we have 3 events, okay? Dancing, singing, and acting. Okay, so in this way we can draw. Suppose this represents dancing, this represents singing, and this is for acting. Okay, now let's see what information is given. So in total we have 90 students. Okay, so the first line is the number of students who did not participate in the acting or dancing competitions are 10, and the number of students who participated only in the dancing. Okay, so only dancing are 15. So only dancing are 15. So we can write 15 here. Okay, so this will represent that 15 students are participating only in the dancing, only in the dance competition. Okay, and then we have the total number of students who participated in the acting competition is 50. Okay, so this is the total number who participated in the acting competition. Okay, so in total we have 50. I'm writing it outside. Okay, and then it is given the number of students who participated in both singing and acting are 20. Okay, so both singing and acting. So both singing and acting, that is 20. 20. Okay, so this entire, okay, this entire is 20. Okay. Okay, I'll write it later. Let's see the other information as well. The number of students who participated in both the dancing and acting are 15. Okay, and the number of students who participated in all the 3 are 10. Okay, so in all the 3, this is the reason for all the 3 events, right? So this is given as 10. Okay, so this I can write 10 here. Okay, now let's read the information again. So the number of students who participated in singing and acting both. Okay, this is 20. So singing and acting both, which means these two. So this is 20. Okay, So this reason is containing 10 students, so this will be 10. Okay, if you add both, that will be 20. Is that clear?
Yes.
Okay, you have to be careful while making the Venn diagram. Okay, so it is given that 10 students. Okay, read the last line first, that the student who participated in all the three. So all the three is this reason. This green is the common for all the three. This is 10. Okay, now we are given that number of students common for both singing and acting are 20. Okay, so singing and acting will be this reason, right? Okay, so that is 20. So 10 is already here, so remaining will be 10. Okay, now we are given that the number of students who participated in both the dancing and acting are 15. So dancing and acting is 15. So which is dancing and acting, okay, which means this area. So this 10 and here it will be 5. So both will be 15. If you add both, it will be 15, which is common for both dancing and acting. Okay, this is, so that's how we have find this value. Okay, now so we have mentioned this one also, this one also, this also. Then we are written that total we have 50 for acting. Okay. So, okay, now tell me what will come here, which are only for acting. So in total we have 50 students, okay, who perform, who take part in acting competition.
25.
Okay. So it will be, so total we have 50, okay. 10 is like, 10 is this 10, which is common in all the three, okay. And then we have this 10, and then we have to add this 5, okay. So now you can see this will be 50 minus 25, which is 25, okay. So 25 students will be there, which are only in acting, okay. Now we have to fill these two places, right? These two. Okay. Now look at this information and tell me how can we find that? Okay, just read the first line. This line. The number of students who did not participate in acting or dancing are 10. So where can we fill it? So 10 students are there who are not in acting or dancing. Okay, so they are only in singing actually. So this 10 will come here. Is that clear? Okay. Now we have to fill this place. So now it is given that in total we have 90 students. Okay. So tell me what value should come here. At this place.
$15.
It will be 50. Yes or no? Just think about it. Total students we have 90. Okay. All the places are filled, remaining this one. Okay. So you can see you just have to do 90 minus all these values. 15 plus 10 plus 10 plus 10 plus 5 plus 25. Okay. So here it should be 15. Okay. 90 minus all the other values. Okay. Now we have made the Venn diagram. Okay. And we have used all the information which is given in this question. Okay. Now let's come to the main question. What is the probability that a student selected at random participated in both singing and dancing? Okay. Now let's see like how many students are there which are both in singing and dancing. Yeah, singing and dancing. So tell me, how many students are there which are both singing and dancing?
Ma'am,
25.
15 upon 90.
25.
Yeah, it will be 25. Okay. So these 15 and this 10. Okay. So 10 plus 15, which is 25. Okay. So that will be 25 divided by the total, which is 90. Okay. Now let's check the answer. Okay. So you can see this is 25. 25 divided by total number of students. Okay. So 25 divided by 90 is the answer. Is this question clear to everyone?
Yes, ma'am.
Okay. So
Yes,
whenever
ma'am.
you are given this type of question, you just try to make the Venn diagram. And after making the Venn diagram, you can just check like whether all the values which you have filled here, they are satisfying the given conditions or not. Okay. You can just cross check. So next is question number 5. What is the probability that a student selected at random has participated in both singing and acting competitions, but not participated in dancing competition? Okay, so both singing and acting, but not in dancing, which means both singing and acting, but not in dancing, right? So you can see from the figure only we can find it.
And
So singing, dancing, sorry, singing and acting, but not in dancing. So you can see this 10. This is for like these 10 students are in singing and acting, okay, but they are not in dancing. Okay, so 10 students are there. So it should be 10 divided by 90. Okay, is this question clear to everyone? Any other question?
from 7th question, ma'am. From 7.1. The first option I want to know I'm not getting. The first option they're giving an answer right. The second and fourth is fine. The first option I'm not clear. How they're
Okay, if even E2, E3 up to En are non-empty disjoint sets, okay, and subset of sample space S, and a set En plus 1 is also a subset of S, then which of the following statement are true? So the first is the sets E1 intersection En plus 1, E2 intersection En plus 1, E3 intersection En plus 1 up to En intersection En plus 1 are disjoint. Okay, so let's take this part, E1 intersection En plus 1. Okay, E1 intersection En plus 1. Okay, so if you take the intersection of these two events, okay, there will be some common elements in both the two. Okay, so those elements will be subset of E1. Okay, we can write it like this. Okay, suppose E1 intersection En plus 1. Okay, so it has some elements, suppose A, B, and C. Okay, so this set will actually be the subset of E1. Okay, because these elements are common in both E1 and En plus 1. Okay, so if you take this set alone, that will be a subset of E1, right? Is this fine to everyone? Yes or no? Okay, so this
Yes,
will
ma'am.
actually be a subset of E1. Okay, so because these elements come from like the intersection of these two. So actually we can say that these elements will belong in E1. Okay, now in the same, In the same way, we can write for the other events, E2 intersection En plus 1. So that will be the subset of E2. Okay, like this we can write, okay, up to En. So we can write that En intersection En plus 1. Okay, so this set will be the subset of En. Okay, is that
Yes.
thing clear to everyone? Okay,
Yes, but
now
how they
it
are
is
telling
given
it
in
is
the
joint?
question. Yeah, just a minute. Okay, so we have got that all these sets, okay, these intersection sets are the subset of E1, E2 up to En. Okay, in the main question it is given that E1, E2, E3 up to En are non-empty and disjoint. Okay, they are disjoint sets. Okay, so they are all they should also be disjoint. Why? Because you can see that this will have some elements ABC which belongs to E1. Similarly, this will have some elements, okay, let's suppose, okay, like this, which belong to E2. Okay, similarly, up to En, they will have some elements, okay, they will also have some elements, suppose XYZ, okay, which will belong to En. Okay, and we already know that E1, E2 up to En are disjoint. Okay, which means that they should not have anything in common. Okay, so these common thing, like these sets will not have anything in common. Okay, so these subsets will also become disjoint. Okay, because if we are getting anything in common in these sets, then the main condition that E1, E2 up to En are disjoint, that will not be satisfied. Okay, so that's how
Awesome, got it.
these intersections will also be disjoint. Okay, any other question?
Ma'am, question number 8, option D, explain.
So which of the following statements are true? Okay, so first three options are clear to everyone?
Yes, ma'am.
Okay, so let's solve the last one. Okay, so it is probability of A complement union B union C. Okay, okay, this is something we have to find. Okay, so first of all, by using the addition rule, okay, we can write it probability of A complement plus probability of B plus probability of C, okay, minus probability of A complement intersection B, okay. Okay, we just have to subtract the intersection of the combination of two events, okay. So probability of A complement intersection of B. Then we will take intersection of B and C. B and C, okay. Then we will take intersection of A complement and C. A complement and C. And then we have to add the intersection of all the three. Okay, so which will be probability of A complement intersection B intersection C. Okay, is this thing clear to everyone? The first line?
Yes, ma'am.
Okay, so by addition rule, I have written this thing. Okay, now I will use the formula which I told you earlier. Okay, this formula, by using this formula, we will prove it. So here, probability of A complement intersection B. Okay, now by using this formula, okay, what can I write there? Probably what will be the value of probability of A complement intersection B? Tell me, what can I write? Just replace A with E and B with F.
Probability of A minus probability of A intersection B.
It will be probability of B minus probability of E intersection F. Oh, sorry, probability of A intersection B. Okay, you can see here we have F. So here we have F. Okay, here we are using B. So it will be probability of B minus probability of A intersection B. Okay. So by using the same concept, we can write it will be probability of B minus probability of A intersection B. Okay, is this statement clear to everyone? Anyone need more explanation? How will I write it?
Yes, ma'am. If once more you can just explain.
Okay. So again, I will make the Venn diagram for these two events. Okay, you can see if you have two events A and B. Okay, this is A and this is B. Okay, if I have to color the reason for A complement intersection B, what will be that? A complement is whatever is outside of A, which means out of this circle. And then we have to take the intersection with B. So this green color reason will be the reason for A complement intersection B. This green color is for A complement intersection B. Is this thing clear?
Yes, ma'am.
Okay. Now let's take the look at the right hand side. So out of B, we have removed the intersection of A and B. Okay, if you add this pink color and the green color, this entire is actually B. Okay, so from the entire B, we have removed the intersection of A and B. Okay, just see this formula.
Yes, ma'am.
Okay, so that's how we can write this. Okay, okay, so we have written the value of this part. Okay, similarly, we can write the value of this thing. Okay, similarly, we can write the probability of A complement intersection C. So that would be equal to what? Now look at this formula carefully and tell me the value of this thing. What will be probability of A complement intersection C?
Probability of C minus probability of A intersection C.
Yeah, correct. Okay. So it will be probability of C minus probability of A intersection C. Okay. Now we will put these two values in this equation number 1. Okay. Suppose this is our equation number 1. So I will put these two values. Okay. So now let's see. Okay. So probability of A complement, I can write it as 1 minus probability of A. Okay. Then we have probability of B plus probability of C. Okay. At the place of A complement intersection B, I will write this thing. Okay. So it will be probability of B. Okay. Minus probability of B intersection C. Okay. Then we have minus probability B intersection C. Okay. The next term is probability of A complement intersection C. Okay. So I will write the value this. Okay. So this is probability of C minus probability of A intersection C. Okay. Next we have probability of A complement intersection B intersection C. Okay, so I have just put the values here. Okay, now you can see that some of the terms will be cancelled. Okay, I will open the bracket here. Just look at all the terms carefully and see. Okay, now we can see that probability of C will be cancelled out. Probability of B intersection C will be cancelled out. Probability of B will also be cancelled out. Okay, now we are left with 1 minus probability of A, okay, plus probability of A intersection C, okay, plus probability of A complement intersection B intersection C. Just check all the terms are correct or not, or anything missing. Is that clear to everyone? Is that fine?
Yes, ma'am.
Okay, everything all correct. Just cross check again. Okay. Okay. Now again, in this term, probability of A complement intersection B intersection C. Okay. So this term also we can use the same formula. Okay. We can write it like this. Probability of B intersection C. Okay. Minus probability of A intersection B intersection C. Just look at this formula carefully. Okay. By using the same concept, we have written this thing. Is that clear to everyone? Yes, no?
Yes.
Okay. Now we will put the value. Okay. Is this clear to everyone? Okay, this is the answer. Just check whether all the terms are same or not. Okay, one term is different. A intersection, it should be A intersection B. Okay, let's check what we have missed it here. So the first line is correct. And then we substitute the value. Just check with me, you all. Okay, so this term is not B intersection C, it is actually A intersection B. Okay, this, no one noticed this thing that I have written a wrong thing. Okay, this will be A intersection B. Just check whether I'm doing everything correct or not. If you find any mistake, you can just tell that I have written something wrong. Okay, now just check.
Ma'am, if we don't want to write all this formula, we can directly draw the Venn diagram and derive this formula, right?
Yes, if you can do by that method, that will also be correct. Okay, you just have to prove that. You can use Venn diagram method or you can just use the formulas. Okay, both the methods are correct.
Okay, ma'am. Thank you.
Okay, it's your choice. Okay, in that case, this will not be cancelled out. Okay, by mistake, I write it wrong. Okay, so that will be A intersection B. Okay, in that case, 1 minus probability of A. Okay, so this term will get changed. Okay, so we have plus probability A intersection B. Okay, minus probability B intersection C. Okay, and plus probability A intersection C. Okay, and plus probability A complement intersection B intersection C. Okay, and then we will put this value. So now here we will have I will write this term again. Okay, so this will be 1 minus probability of A plus probability of A intersection B minus probability of B intersection C plus probability of A intersection C plus. Now here I will replace this value. So this will be probability B intersection C minus probability of A intersection B intersection C. Now we can see that these two terms will be cancelled out. Okay. Now this is correct. So the value is 1 minus probability of A plus probability of A intersection B plus probability of A intersection C minus probability of A intersection B intersection C. Okay, now you can see all the terms are correct. Okay. Is this question now clear to everyone? Any other questions?
How we find a event simultaneously or without simultaneously, or with replacement or without replacement?
Okay. So simultaneously, which means it is happening at the same time. Okay. So by the given question, you have to understand this thing that whether the two events are happening at the same time or not. Okay. With replacement, without replacement is like you have to do selection. Okay, suppose you have a bag in which you have some balls. Okay, so maybe you are selecting a ball first. Okay, and then you are putting the ball back into the bag, and then you are selecting the second ball. Okay, it's this situation is with the replacement. Okay, you are keeping the ball again in the bag, and then you are selecting the next ball. Okay, so this is with replacement. If suppose you have drawn one ball, you are not keeping it back. You are not keeping it back into the bag, and then you are selecting the second ball. Okay, which means you are doing without replacement. Okay, so it depends on the contest which is given in the question. Okay, if you are doing two things at the same time, which means it is simultaneous. Okay, any other question?
Ma'am, question number 10.
This one?
Yes, ma'am.
Okay, this we already discussed.
Okay, so I missed.
Yeah. Okay. Still, I'll give you the overview. The solution is already given. Okay. So the question is that in a particular game, the player needs to throw a dart on a circular board. Okay, and the radius is 8.5 units. Okay, and the main question is that we have to find the probability that the points scored by a player should be the multiple of 4. Okay,
Yes,
so
ma'am.
multiple
So,
of 4, which means
ma'am, my only query here is that we should not include 0 because 0 is also multiple of 4. So,
no, actually, the solution is little bit faulty. We have to include the 0 point as
yes,
well.
that's okay, ma'am. That was my confusion.
Yeah, we have to include that.
Include 0 here. So, this
Yeah, we
answer
will
is
correct the
correct.
solution. Yes, we will correct the solution.
Okay, thank you, ma'am.
Any other question?
Week 6 EMQ practice assignment.
Week 6 is already done. You did not ask the question there?
No.
You should have asked there. Apart from that, from week 7. Any other question you want to ask? Anyone?
Ma'am,
Hmm.
I have a question about the reattempt qualifier.
Okay, what?
So, I'm actually giving a reattempt on this November 23rd. So, I just want to know, will I be eligible to write the December one, the final one?
Okay. These kind of questions you can ask to support team. Okay, they will guide you on that.
Okay, ma'am. Okay, thank you.
Okay, anyone else having any conceptual doubt? If no one has any doubt, then we can end the class. Anyone? Anyone having any doubt from week 7?
No, ma'am.
Okay, if no one has any doubt, then we can end the class.
Bye, ma'am.
Thank you, ma'am.
Okay, thank you, everyone.